Hello, my dear friends. Let's continue to study the operation of various electrical equipment, and today we will analyze the operation and connection of an optical or rather photoelectric contactless sensor from the Russian company Beskonta Electronics. Beskonta started producing this sensor just recently, so today when I make this video there is no information about it even on their website. I have already produced a review on the inductive sensor, and there will also be another review on the capacitive one. They have different principles of operation, different ways of application, but they connect in about the same way. And I will demonstrate this with the help of my universal stand. The sensitivity range of this model is from 10 to 22,000 millimeters. As you know, it all depends on the specific task, and you can't just order 20 sensors or more or less. Now I'm going to move the camera closer and take a closer look at this device. Okay, there is an adjustment screw that can be used to adjust the sensitivity of the specified range. The sensor housing is plastic, meaning it's used to operate in normal rooms. This sensor is connected via a 4-pin connector and is fixed with this nut. There are special slots in the contact group, so you won't be able to insert the sensor by mistake. There is no common negative here, that is, the load is switched via a positive wire. When the sensor is triggered, it changes the position of the normally open and normally closed contacts. You can see the principle of operation of the optical sensor in the picture. I think that's everything is roughly clear here. If you apply a DC voltage to the input, then the modulator modulates a signal of a certain frequency. Each signal is unique, so that different sensors don't affect each other's work and do not intercept neighboring signals. First, the signal is emitted, then reflected, then received, then decoded, and if the value is within the range of operation, the sensor activates and switches contact. This sensor is of a diffuse type, that is, it reflects radiation from the object itself. Accordingly, the scope of application of this sensor is very wide. These are ordinary conveyors with all kinds of boxes, molten workpieces. The sensor is in a metal case will be used there, of course. The sensor also reacts to both magnetic and non-magnetic materials. These sensors have a high switching speed of up to 30 kHz, and they are also insensitive to various electromagnetic interference. Obviously, it's better to position these sensors horizontally or with the lens facing down, so that dust does not settle on them. Here I have a power source for the device itself and for the load. We supply 220 volts, and a 24 volts power supply is powered from them. The sensor is stable from 10 to 30 volts. Here 2020 volts goes to the load itself in the form of light bulbs, but it can also be an electric drive. The load is connected via the closing contact of a relay, and the relay coils, already as a load, are powered from the switching contact of the sensor itself. So I supply power, and I simulate some kind of object passing by. The sensor is triggered, the contacts inside it are switched, and the relay coils is powered. Now the relay is triggered and supplies power to the load, and then some actions happens. You can complicate the circuit and connect a time relay. For example, if the photo sensor has not been activated for some time, a signal is sent. You can build it into the wall and put some kind of object. If someone takes it, the sensor will also work. Okay. Wee. Well, you can come up with dozens of applications yourself. That's all on this topic for today. I hope this video turned out to be interesting and useful for you. I wish you all success in your work and safe work. Bye.